So back to what we were talking about. Let's see, 58, number 20. I'll go back over that one. X plus 2 times x minus 2. 22 was 3x plus 1 times 3x minus 1. 24 was x plus 5 times x minus 5. And then 26, you had to bring out a 9 first, and then it was 2x plus 1 times 2x minus 1. Next question was 32. 32 was x plus 5 times x plus 5. 38. Of course, that one's not here. This is R5. $38 was x plus 5 times x squared minus 5x plus 25. And then 40 was, you could have said a negative, pulled out a negative, and then 2x minus 3 times 4x squared plus 6x plus 9. Or you could have done 3 minus 2x times 9 times, ugh. You could have also written 3 minus 2x times 9 plus 6x plus 4x plus 2. 4x squared. Let me read it again. 3 minus 2x, that would be your first one, and then times 9 plus 6x plus 4x squared. That was number 40. And then the last one is 42. You could have said 4 minus 3x times 16 plus 12x plus 9x squared, or you could have pulled out a negative, and you could have said 3x minus 4 times 9x squared plus 12x plus 16. All right, any of those that you guys want me to do? To the chat. Any of those you guys want me to do? $42. Yeah, I was thinking 42. A little bit more difficult. All right, so remember when we talked about our sum or difference on Thursday, the difference of cubes, remember, it was like x cubed minus 1. And hold on, I want to change the board view. And you would keep the first one minus and the other one plus. There we go. So for this one, it was x minus cubed. Remember, you would keep the minus, and then this one would be plus, right? And you would do the cube root of this and the cube root of that. And then to get this one, you would square the first term, square the last term, and then multiply the 2 in the middle, okay? So if you're looking at this one, we know it's a difference of cubes because this is a perfect cube, this is a perfect cube, and this is a perfect cube. Do you guys remember that? So what is the cube root of 64? Cube root of 64. What are three numbers that are the same that multiply to give you 64? All right, so 4 times 4 times 4. 4 times 4 is 64 times 4. Would that give you, 16? Yeah, 16 times 4 is 64. Yep. 16 times 4. Does that give you 64? Yes. All right, so 4 is correct. And we're going to do our minus. And then we're going to do the cube root of 27. What would that be? 3. Good. And then we have our x there. Everybody with me? All right. Then we are going to fill this in. This is going to be a plus here. I'm going to square the first term. So that's going to be 16. Square the last term. So that's going to be what? What would that be? What's squaring 3x? What would that be? Squaring 3x. Squaring 3x, guys. That would be 3x squared, which is the same thing as 3x times 3x, which is, yes, 9x squared. And then to get the middle term, you multiply these two. And so what's 3x times 4 is going to give you 12x. So this is the easiest way to do it. I mean, you could have brought out a negative, and then it would have been it would have changed it to a sum of cubes, but this is the easiest way to do it, in my opinion. It's just knowing the pattern. Questions on that one? All right. Okay, so we talked about the perfect squares, difference of squares, difference of cubes, sum of cubes. Perfect squares is just breaking it up into a perfect square. So the next thing I want to talk about is factoring trinomials. Actually, let's go ahead and do factoring 4 terms. Go ahead and do that. All right, so get out your notes if we're done, if you are good on the homework. Get out your notes. So I don't see a lot of camera faces here. All right, so when we're talking about factoring by 4 terms, you're going to look at how many terms you have. If you have 4, you can either do it by grouping, or we can do the reverse box. Which one are you guys more comfortable with? Put in the chat box. I'm just curious. Do you guys know when I say reverse box, you put them inside the box versus on the outside? And then grouping, we're going to group. So we'll show you both. Grouping, Emily said grouping. Or you guys just don't know what I'm talking about. Box, okay. So for example, of what I'm talking about here, let's see. Let's do 4 terms. Box, reverse box. Yep, I'm going to show both. I'm going to show both of them. All right. So here's an example. We have 1, 2, 3, 4. 4 terms. Okay. If I was going to solve this factoring by grouping, what I would do is I would pick 2 terms that have a like term in them, and I would group them. So I'm just going to pick, I'm going to do these 2, and I'm going to do these 2. Okay. So I put a set of parentheses around them. It's called grouping them. Okay. And then I pull out the GCF of this. So what do these 2 have in common? Well, this one has 2 x's and this one has 2 x's. Everybody see that? Like terms here. You're going to pull out your greatest common factor. So I can't just bring out an x because they actually both have 2 x's in common. So I'm going to bring out an x squared, and then I'm going to factor out the x squared and leave what's in parentheses. Your goal is in the parentheses, you want to have the same thing in it. Okay, so this one's going to end up being x squared times what gives you x cubed. We need an x. We bring down our minus sign, and then I need a 4 here. Does everybody see that? So x squared times x gives you x cubed. X squared times negative 4 gives you negative 4x squared. Then I'm going to do the same thing to this one. What do these 2 have in common? What's the GCF of 2x and 8? A 2, good. So I bring out a 2, and then what should happen, if I did this correctly, is whatever's in here, it should be the same thing as what's in here. So 2 times what's going to give you 2x? We need an x. a minus, and 2 times what's going to give you -8, a 4. And notice how this is the same as that, right? So we bring that down. That's going to be one of our factors. And then what you have left over here is going to be your other one. So this is x squared, and this is a +2. So it would be +2. And that's called factor by grouping. Have y'all seen that before? Hopefully. The other one is the reverse box. And so what you would do is you're literally just going to put these 4 terms inside the box. So I have an x cubed, a -4x squared, a +2x, and a -8. And then I pull out what they have in common. So what do these two have in common? They both have an x. What do these two have in common? They both have a negative. So I'm going to go ahead and bring out the negative. And they both have a 4 that can go into both of them. Then you go across. So what does x cubed and -4x squared have in common? They both have an x squared. And then what do 2x and -8 have in common? They both have a 2. And then I check this. X squared times x gives me x cubed. X squared times -4 gives me -4x squared. 2 times x gives me 2x. 2 times -4 gives me -8. And then what's on the outside is your factor. So x -4 on the top, and then x squared plus 2 on the bottom. And notice that both of these are the same. So that one is reverse box, okay? And then the other one is grouping. So now, seeing both of those, for those of you that have, it's been a minute, which one do you guys like better? I'm just curious. I personally like the reverse box better, but some people have like grouping, which is fine. Looks like more like grouping than the reverse box. Okay, awesome. All right, so that's how you do 4 terms. I'm going to give you guys one more of these to try real quick, and then we're going to move on to our 3 terms. Does everybody have this down? Okay, seeing some thumbs up. All right, I'm going to erase this. It is recording, I hope. All right, so let's do another problem. All right, you guys try this one real quick. 3x squared plus 6x minus x minus 2. All right. So, I'll do both ways again, just to kind of recap over it. Okay. For those of you that like the grouping or the box, you should get the same answer either way you do it. I'm going to group, and you don't have to always group the first two and the last two. We could group these two and these two. Okay. So if I'm going to do 3x squared minus x and then 6x minus 2, what do these two have in common? They both have an x. And then I'm left with a 3x minus 1. What do both of these have in common? They have a 2, and I'm left with 3x minus 1. And then again, you pull down what they both have in common. So 3x minus 1 is one factor. And then what you have left over, which would be x plus 2, is the other factor. Again, you could have grouped these two and these two. You would have pulled out a negative, and you still should have gotten the same answer. All right, if I'm going to put these in the box, we've got 3x squared, 6x, negative x, and a negative 2. I'm going to go up and down first. So what does 3x squared and negative x have in common? They both have an x. What does 6x and negative 2 have in common? They both have a 2. What does 3x squared and 6x have in common? They both have a 3x. And then your negative is going to be down here at the bottom. So a negative 1 is what I pull out. And so again, you get x plus 2 on the top and then 3x minus 1 on the bottom. Same answer. Everybody get this? Questions? Questions on 4 terms? All right. So now we're going to look at 3 terms, factoring 3 terms. We've done 2 terms. We've done 4 terms. Now we're going to do 3 terms. When you have factoring 3 terms, and again, all of these, you still need to pull out the GCF first, if possible, on all of these. So the first thing to look at when you're factoring trinomials, if the leading coefficient is 1, okay, then you can do the guess and check method. And you don't really have to do as much, okay? So if leading coefficient is 1, use guess and check method. So what do I mean by that? So if I gave you guys this example, x squared plus 7x plus 10. Okay, I want to factor x squared plus 7x plus 10. The leading coefficient, meaning this number here, what would this number here be? What's in front of this x squared understood as? A 1, correct. Okay, so the leading coefficient at this 1, then all we have to do is we have to look at our last term, which is 10, and we want 2 numbers that multiply to give me that 10, but add to give me the middle term, which is 7 here. And what would that be? What are 2 numbers that multiply to give you 10, but add to give you 7? 5 and 2. Good. And so what that means is this becomes x plus 5 times x plus 2. That's the guess and check method, okay? We found our 2 numbers that multiply to give you those. And if you check it, x times x gives you x squared. Then you would do 2 times x is 2x, and 5 times x is 5x, and 5 times 2 is 10. Okay? So it's really easy when it's just a 1 here, because you literally just multiply, get the 2 terms that multiply to give you the last term, but add to give you the middle term. And that's going to be your factors. All right, so let's do a few more of these. I got this one? All right. Let's do All right, you guys go ahead and do these three. X squared minus 10x plus 16. X squared minus 7x minus 8. And x squared minus 2x minus 8. You should see everybody working. Is everybody all done? All right. So these are pretty easy then, right? So again, notice these all have a coefficient of 1 in front, so we can do the pretty quick, easy guess and check method. You look at the last term, which is 16. I want two numbers that multiply to give you 16, but add to give you negative 10. What would that one be? Two numbers that multiply to give you 16, but add to give you 10. Good. So negative 8 and negative 2 multiply to give you 16, and then negative 8 and negative 2 add to give you negative 10. So this one, you should have gotten x minus 8 times x minus 2. Questions on that one? All right, the middle one, I want two numbers that multiply to give you negative 8, but add to give you negative 7. What did you get for that one? All right, Finley said negative 8 and positive 1. Let's check. Negative 8 times positive 1 gives you negative 8. Negative 8 plus positive 1 gives you a negative 7. Yes. So this one would be x minus 8 times x plus 1. Questions on that one? All right, the last one. Two numbers that multiply to give you a negative 8, but add to give you a negative 2. All right, I'm seeing two different answers. We've got a positive 4 and a negative 2, and we've got a negative 4 and a positive 2. So negative 4 and positive 2 would give us the negative 2, which is what we want. So it would be x minus 4 times x plus 2. So we got to be careful on your sign on these, okay? Questions? Everybody good with factoring 3 terms when the coefficient is 1? All right. So now let's look at factoring trinomials when the leading coefficient is not 1. I'm going to erase this. If everybody's good, everybody got it? All right. Okay. So factoring 3 terms when leading coefficient is greater than 1. This is the greater than symbol, greater than 1. So notice here on this one, we have a 2 here as the leading coefficient is not 1. When you have a number that is greater than 1, the first step you're going to do is you have to be able to multiply the last term and you multiply it by the first term. So I'm going to write over here, step 1, multiply last term by first term. Okay. So before, when it was 1, you only had to look at the last term because really it was just saying like 10 times 1, which is 10. So 3 times 2, so we want 2 numbers that end up multiplying to give you 6, okay? And it's the same process. You're going to find the factors that multiply to give you that number, but add to give you the middle term. So it's the same process here. So step 2, find factors that multiply first and last term and add to middle term. So 2 numbers that multiply to give you the 3 times the 2, which is 6, but add to give you the middle term, which is 5x. So what would that be? Good, Anna. 3 and 2. All right. So then the last step here is you can't do the guess and check method here because the number here, you have a number here. So what happens is this 5x now is going to break up into your factors. This 5x now will become a 3x and a 2x, which is the numbers that we got here. And we're going to break this up now into 4 terms, which is why I like to teach the 4 terms first before we do the 3 terms. Does that make sense? So you break up your 5x, your middle term, into your 2 factors that we got, which was a 3 and a 2. And so I'm just going to rewrite it with 4 terms. And then now we can just do what we did before. You can either factor it by grouping or you can do the reverse box, whichever one you want. So I'm going to do the reverse box. And I'm going to put these in 2x squared, 3x, 2x, and a 3. And I'm going to pull out what they have in common. These 2 both have a 2x. These 2 both have a 3. These 2 have an x. And those have just a 1. And so now my factor becomes 2x plus 3 times x plus 1. And if you guys use grouping, you should get the same thing. Questions on this? Have you guys seen this before? I hope, right? So I should write up here step 3. Create 4 terms and factor by grouping or reverse box. All right, I'm gonna let you guys finish writing that for a second, okay? All right, so let's try 3. We're gonna do some more examples of this. Everybody got all this down now? All right. All right, let's try this one. I'll give you one more. All right, I want you guys to go ahead and try both of these using the method we just worked on. Everybody should be working on these 2 questions. Everybody done? No? Okay. No? All right, keep working. Give you 1 more minute. Well, I'll give you 3 more minutes. Okay. All right, we ready? Everybody ready? All right. So looking at this one, notice again, we have a number that's greater than 1 here. So I'm going to do 1 times 3. I want two numbers that multiply to give me 3, but add to give me 4. So what would that be? There's really only one option. 3 and 1, right? Okay. So this is going to break up into a 3x and a 1x. And we can put those 4 terms in a box, or we can do grouping. I'll do grouping this time. For those of you that like grouping, I'm just going to rewrite this so it's all 4 terms out here. I'll group the first 2 and the last 2. What do these 2 both have in common that I can pull out? A 3x, and I'm left with an x plus 1. What do these 2 have in common? They only have a 1, and I'm left with an x plus 1. Notice these are what's in parentheses that are the same. So I'll pull out an x plus 1, and then I have what's left over, which is a 3x plus 1. So you should have gotten x plus 1 times 3x plus 1. Did everybody get that? Seeing some shaking your head, yes? Questions on that one? All right. The last one, I'm going to do -8 times 3. So I want 2 numbers that multiply to give me what's -8 times 3. That's going to be what? -24. And I want them to add to give me my middle term, which is a -2. Anybody know what that's going to be? Let's see. We got 12 and 2. That's not going to give me 2. I've got 8 and 3. That's not going to give me 2. Okay, -6 and 4. Good. All right. So this is going to break up into a -6x and a +4x. I have 4 terms now. I'm going to use the reverse box on this one. I've got 3x squared, I've got a -6x, I got a +4x, and I've got a -8. Okay. What do these 2 have in common? They both have an x. What do these 2 have in common? They both have a negative, and I'm going to pull out a 2. What do these 2 have in common across? They have a 3 and an x. And then what do these 2 have in common? They have a 4. And then I'm going to check it. 3x times x gives you 3x squared. 3x times -2 gives you -6x. 4 times x gives you a 4x. 4 times -2 gives you a -8. Okay. And what I'm left with is x minus 2 times 3x minus 4. Now, I personally like the reverse box better just because it keeps it a little bit organized. That is my preference, is the reverse box. But again, I really don't care which way you guys do it, as long as you do it correctly. Did everybody get this? X minus 2 times 3x. Oh, this should be a plus 4. Excuse me. Everybody get that? X minus 2 times 3x plus 4. Questions on that? Okay. All right. I want you guys to practice some more of these tonight. And we were going to go over them. So, page 59. Problems 80, 84, 86, 94, 100, 102, 108, and 124. Okay, page 59, question 80, 84, 86, 94, 100, 102, 108, and 124. Everybody does have their books, right? Okay. Making sure. All right, we're going to stop here. We only have 2 minutes left. These are the factoring questions. It's kind of a mixture of them. And that's kind of the overview of factoring. Remember, there is a factoring cheat sheet I would suggest printing out under the Moodle notes, which I don't even know if it's open yet. Is it open? It's probably not open yet. But it will be open Friday. So we are ahead of the online portion, but I like to be ahead in class. So that way you guys can get your online stuff done a little bit earlier. But for now, if you guys have not done the R4 quiz, go ahead and get that done. And then also the intro discussion too. Okay. All right. We will see you guys on Thursday.